very good evening to all TS GENCO aspirants. I, Muhammad Waid Ulagh, faculty member, welcome you all on behalf of ACE Engineering Academy and ACE online platform. Today in this session, we are going to discuss the preparation strategy for the subject called as Theory of Machines and Vibrations. So before coming to the session, before beginning the session, first try to understand the exam before you are preparing for the examination. What type of questions will be asked in the examination? Basically, guys, they are going to ask a simple statement or standard statements will be given to you. And out of those statements, you are supposed to pick up the right statement, or they will be giving a numerical problem to you which is of a single formula based or very simplified calculation. So all the questions which are there in the TSPSC examination or TS GENCO are almost of similar pattern. So it is very easy for you to crack the exam also. Now let us begin the session and identify what are all the topics included in the theory of machine subject. So here this subject is going to comprise the topics like first one would be analysis of mechanisms, second one would be flywheels, third one is gyroscope, and fourth one is gear and gear trains, fifth one is cam and followers, next is balancing of masses, governors, and mechanical vibrations. So these are the 8 topics which have been listed under this subject. Now let us identify what are the topics or what are the important subtopics from where you can expect the questions from these chapters. So before that, you can take the list of reference book. So Theory of Machines by S.S. Ratan or Thomas Bevan, you can refer that. Okay. And next is under analysis of mechanism. Let us see the subtopics here. So the first one is kinematic pair. Kinematic pair means basically they will be giving you a statement by a statement based question, or else they will be giving you a definition for a link or pair for a pair, or they might ask you the classification of the pair also. Okay. Next is degree of freedom. So from the degree of freedom, they might be giving you some arrangement which is comprising of connected links, and then for that arrangement you are required to calculate the mobility of the mechanism. Okay. And the third one is Grashoff's law. So most of the time, what is the observation that from these two topics, especially degree of freedom and the kinematic pair, we have seen more number of questions being consistently repeated. Grashoff's law, they have not repeated, but they have only given the, they have given a question or formula, single formula. What is the Grashoff's law? That question was repeated. Okay. Next is the inversions of the mechanism. So inversions of the mechanism, here what is included, that is 4-bar mechanism. Next is slider crank mechanism and double slider mechanism. So from here also you are required to identify which of the following inversions, which of the following mechanism or chain is having the inversions. So accordingly you have to map that. So from here also inversions, especially more number of questions has been repeated in the various public examinations. Okay. And next is quick return ratio. So from quick return ratio, they have not repeated the questions. Next is kinematic analysis, that is velocity and acceleration analysis. Especially guys, here from this chapter, kinematic analysis, they have given the questions relating to how many number of eye centers would exist for a given linkage, or they are asking you what are the components of acceleration or radial acceleration or tangential acceleration, and especially they might ask you about the direction of Coriolis acceleration. So questions are kept very simple. Next one is dynamic analysis of crank slider mechanism. So from here also you can expect a formula based question only, or they might ask you what is the term or what is the force acting on the piston and how that can be resolved along the connecting rod, and similarly force on the connecting rod is resolved along the crankshaft and perpendicular to the crankshaft. So that is how you are going to calculate the value or the expression for torque exerted on the crankshaft. So these are the list of subtopics under the chapter called as analysis of planar mechanism. Let us go to the next one. So next chapter we are dealing is flywheels. So here flywheel, we are seeing the application of flywheel for two different types of segments. Or first one would be the prime movers. Prime movers include the IC engine, the steam engine, okay, and second application would be the punching press. So here generally in the punching press we will be seeing the fluctuation of energy happens during the cutting operation, or before the cutting operation and after the cutting operation. We will see large amount of fluctuations in energy happens. Okay. So next is under that, next chapter is gyroscope. Gyroscope, here we are going to mainly discuss the effect of gyroscope on the ship, aeroplane and a shaft carrying rotor. So these are simple applications. Only these three applications were included. Mostly they have focused on the aeroplane and ships, guys. Going to the next chapter is gear and gear trains. From this chapter, guys, especially they have given many number of questions from the classification of gear. Classification of gears include spur gear, helical gear, bevel gear. So for all these types of gears, how the forces are getting resolved and what is the description of teeth, okay, and how the teeth cross section, is it constant or it is varying, all that description is included in the classification of gears. Okay, next is very important, that is terminology relating to spur gears. So terminology relating to spur gears, we have seen many number of questions, especially describing the nomenclature of tooth, that is it is addendum, flank and face portion on the teeth, similarly top land and bottom land and pitch circle. All these parameters comes under the topic called as nomenclature of gears. So simple statement will be given to you. You have to pick up a statement, or you have to pick up the correct statement from the given set. Okay. So next one is the interference in the gears. So interference in the gears, generally this topic they have given least preference in the public examination. Next is gear and gear trains. In the gear and gear trains, based on the arrangement of axis, they are giving you a question, what is the type of gear train when the two gears are having single axis only. So that we call it as compound gear. Like that we have reverted gear train also. Okay. Next one is cam and followers. Under cam and followers, we have only two topics. One is the classification of cam and followers, and another one is motion analysis of cam and followers. Okay. In the motion analysis, we generally talk about uniform velocity motion, uniform acceleration motion, and simple harmonic motion and cycloidal motion. So these are all four set of motions included in the syllabus. Next one is balancing of masses. So here under balancing of masses, we have two types of problems. First problem is balancing of masses, or I should say rotating masses. These rotating masses can be in the single plane or in the different planes. Okay, and the second type of problem we have is balancing of reciprocating masses. Okay, now after this, the next topic we have is governors. So under governors chapter, guys, we have only centrifugal type of governors. Under centrifugal governor, we are going to focus only on the Watt governor, Porter governor, Proel governor, Hartnell governor. Hartnell comes under the category of spring-loaded governor. So these are all the governors which are included. And next is controlling force. Controlling force, especially in the governors. So from here, you can expect a reasoning question. Okay. Now let us see the next chapter. Next chapter is this is the last one, that is mechanical vibrations. So under mechanical vibrations, free undamped vibrations. Next is free damped vibrations, forced vibrations, and followed by whirling of shafts. So generally, guys, the observation is here, that is they have asked mostly the question based on the arrangement of springs, whether the springs are in series or in parallel combination. Some complex arrangement will be given to you. So you have to use the relations which are describing the series combination and parallel combination, and then with those two set of concepts, you have to derive the equivalent system of the given problem. Okay, so that way, that is the observation generally in the most of the public examination, guys. Okay, now let us see some few sample problems where we can see all these topics getting covered. Okay, so let us start our first question. Choose the correct statement. First one, a sliding pair has incompletely constrained motion. So sliding pair, that is a prismatic joint. So prismatic joint is having incompletely constrained motion. So here sliding pair is having only 1 degree of freedom. DOF is equal to 1. So when DOF is equal to 1, we call it as completely constrained pair, or we call it as kinematic pair. Okay, so this is called as completely constrained pair. Or you can even call it as kinematic pair. So here I can say incompletely constrained pair. This incompletely constrained pair means it is having degree of freedom greater than 1, or if it is, yes, if it is greater than 1, then you say it as incompletely constrained pair. But prismatic joint or sliding pair is having only 1 degree of freedom, and it is an example of completely constrained pair. So here the first statement is incorrect, guys. First statement is false. Okay. Second one, a pair of friction disc constitute a lower pair. This arrangement, pair of friction disc, where we are going to use? We are going to use this arrangement in the clutch mechanism. In the clutch mechanism, the friction disc will be in contact with each other. So when the friction discs are in contact with each other, definitely there has to be a surface type of a contact. So this is going to form a lower pair. Option B is correct answer. Okay. Next is rectilinear motion of the piston is converted into rotary motion by slider crank mechanism. Yes, in the crank slider mechanism, we are converting the reciprocating motion or the gas force which is exerted on the piston side. It is converted into rotational work by using this arrangement. Okay, rotational work is obtained at the crankshaft. So here option C is also a correct answer. Similarly, automobile steering gear is an example of higher pair. Yes, guys, gear and pinion is an example of higher pair. Please do remember that. So although you may see that gear teeth may have somewhat of surface type of contact, but guys, we are not seeing what is the type of contact between the teeth. When the two gears are in mesh, they are represented by two pitch circles in contact, and these two gears which is represented by pitch circles in contact, about this point they will undergo pure rolling motion. Both the gears will undergo pure rolling motion, and this point we call it as pitch point. Yes, one more thing to tell you, in this gear and pinion arrangement or in the higher pair, we will be finding the rolling motion as well as slipping motion. That will be happening here. So that is why, guys, we will see some loss occurring here. Okay, so gear and pinion is an example of higher pair. Whether it is rack or pinion also, it is still the example of higher pair. Okay, so here we will see there is a rolling action between the two gears about this point, which is called as pitch point. So statement D is also a correct answer. So now what are all the options which is giving the correct statements? That is option D. You can see here B, C and D are included, right? Let us go to the next problem. If n number of links are connected at same joint, the joint is equivalent to. Now guys, here if we are connecting the links or at a node or at a point, if we are seeing two links connected, we call it as binary joint. We call it as binary joint. Okay, Similarly, at a node, if I am connecting 3 links, let us say this is link number 1, link number 2 and link number 3. So now when we are connecting here 3 links, what happens between 1 and 2? Or let us first assume the arrangement here. So I am placing link number 1 in the front, behind the link number 1 there is link number 2, and behind link number 2 there is link number 3. So which means that the link number 2 is in between link 1 and link 3. I repeat, link 2 is sandwiched between link 1 and link 3, which means that there is a physical contact between link 1 and link 2. There is a physical contact between 2 and between 3. Correct? But there is no physical contact between 1 and 3 because 2 is sandwiched between link 1 and link 3. Right? So that is why I can count here revolute pair as 1, 2 and I can count here revolute pair as 2, 3. But unfortunately, I cannot count R1, 3. Reason is that between 1 and 3, link 2 is placed. So that cannot be counted. So if we are using 3 links to join, or if the 3 links are joined at one nodes, we are able to find 2 joints. Similarly, if you can consider 4 links, 1, 2, 3 and 4 links at a joint or at a node, which will say, or let us see how many number of joints are formed. See, I will assume that link 1 is in the front, behind 1 link number 2 is there, behind 2 3 is there, and behind 3 4 is there. So I will assume that 2 and 3 are sandwiched between 1 and 4, which means there is a contact between 1 and 2, there is a contact between 1 and 3, there is a contact between 2 and 3, and there is a contact between 3 and 4. So 2 and 3 are sandwiched between link 1 and link 4. So between 1 and 2 there is a physical contact. Between 2 and 3 there is a physical contact. Between 3 and 4 there is still physical contact. But between 1 and 3 no physical contact. Between 1 and 4 there is no physical contact. Between 2 and 4 also there is no physical contact. Because between 1 and 3 2 is placed. Between 1 and 4 2 and 3 are placed. Between 2 and 4 link 3 is placed. So no physical contact. So I cannot count. Here if the link is connected, or at a node if we are having n number of links, or if we are having 4 links, then we are able to obtain 3 joints. If we are having 2 links or 3 links, we are able to obtain 2 joints. So here the correct answer will be n-1 types of binary join. This is an example of ternary pair. And this is an example of quaternary pair. So in this, we will be able to find n-1 number of joint. Okay, option A is the correct answer here. All right, let us go to the next question. So in the next question, the displacement of the piston of a reciprocating engine is equal to dash. Yes, guys. So here, I don't suggest you to memorize the formula, but I suggest you instead learn how the formula can be derived. Allow me to do a very small derivation over here. So whenever you are here, they are asking you to derive the expression for piston displacement. So piston, when it is at the extreme position, when the piston is at the extreme position, so that could be inner dead center or that could be outer dead center, but we generally consider as inner dead center. So when it is at the extreme position, let us say this is R is the length of the crank and L is the length of the connecting rod. So at the extreme position, this distance from the crank center will be R plus L, Similarly, this distance, or let us say it is making an angle of theta and the connecting rod is making an angle of beta. So this distance, when it makes an angle, we will be writing this as R cos theta plus L cos beta. Okay, and this expression or this distance will be the piston displacement. This distance will be the piston displacement. Let us write here. So x will be equal to r plus L minus of L cos beta plus r cos theta. All right. And one more thing to tell you guys. Here, this opposite side can be expressed as a height for both the triangles. So this opposite side can be written as r sine theta, or it can be also expressed as L sine beta. Okay, L sine beta it can be expressed. So r sine theta is equal to L times of sine beta. So sine beta is equal to sine theta divided by, this is L by r, guys, or which is equal to sine theta by n also. Okay, and we can write this as cos beta equal to root over 1 minus sine square beta, or this can be written as root over n square minus sine square beta whole divided by n square it is. All right. Now guys, here you can use this equation and differentiate this equation. You can get the angular velocity of connecting rod, and if you further do the differentiation, you are going to get the angular acceleration of connecting rod. So this equation you are supposed to remember and perform the differentiation if you are interested in calculating the angular velocity of connecting rod and angular acceleration. That is, beta is defining the rate of change in the angular position, or change in the angular position of connecting rod, I should say. d beta by dt is going to define the rate of change in the angular position of connecting rod. All right. So now let us come back to this equation. We can write here x, and let me pull out r common from here. This can be written as L by r plus 1 minus, this will be L by r, and this cos beta can be written as root over n square minus sine square beta whole divided by n square under root, which is equal to n only, plus cos theta it is. Cos theta it is. All right. So we have expressed that r as L by r as equal to n. So this can be written as x is equal to r into, this is n plus 1 into, this is L by r is n, n will get cancelled. This will be cos theta plus root over n square minus sine square theta. This will be the expression for piston displacement. Okay. So if you observe, the option A is the answer here. Option A is the answer. That is 1 plus n minus cos theta minus n square, root over n square minus sine square theta. Now if you differentiate this expression, okay, I'll give you the result directly. If you differentiate this, you are going to get the velocity of piston, which is r times of omega into derivative of cos is sine theta, or minus sine, this minus sine will be multiplied, and derivative of this will be 2 or sine 2 theta divided by 2 times of n. This will be the velocity of piston. Similarly, the acceleration of the piston, if you differentiate this further, you are going to get it as r omega square times of derivative of sine is cos theta plus derivative of sine 2 theta is cos 2 theta into 2 divided by 2 times of n, so which is only cos 2 theta by n it will be. Okay, so these are few important results which you are supposed to remember, especially from the analysis of crank slider mechanism. Now as per this question, Option A is the answer, guys. Okay, option A is the answer. Now let us please remember these results and learn how to write this expression. Okay, so spend some time, but although they will be asking only you either the displacement or the velocity or the acceleration. It's simple mathematics. Now let us move to the next question. In which of the following mechanisms the Coriolis component of acceleration is existing? Okay, so Coriolis acceleration will be existing when there is a sliding member, present on the rotating frame. Okay, when there is a sliding member on the rotating frame. Now let us check. If we draw the shaper mechanism, or I should say crank slotted lever mechanism, in that the piston will be there and this is a slotted bar. Okay, so this slotted bar is undergoing rotation about this pivot point, and slider is going to move along the slotted bar. Okay, on the rotating link we should be having a sliding member. Or if you can take an example, if a bowler is trying to bowl and on his hand there is not a watch, there is a bracelet instead, or a loosely contact bracelet is there, that bracelet tends to slide on the wrist. Okay, so due to that sliding motion of the bracelet, and plus the bowler is trying to rotate his arm about some axis, then in that case we will see Coriolis acceleration will exist. So this is not a correct example, but just to get or just to understand where this Coriolis is going to exist. Okay, this is one unconventional example I have taken. Similarly, even in the Whitworth mechanism, the shortest link will be fixed, and in this there will be definitely a slotted bar. This slotted bar will undergo rotation, and there will be definitely a slider present. Okay, so here also you are able to see on a rotating body there is another body present which is having some relative motion along the rotating body. Okay, then the Coriolis acceleration will exist. Even in the oscillating cylinder also you will be able to see that is what we call the piston rod will be forming the prismatic joint with the oscillating cylinder. This cylinder is going to oscillate and the piston rod is going to experience to and fro motion. So on this we are able to see once again there is a sliding element on the rotating link. Alright, so in all the three cases Coriolis acceleration is going to exist. So generally the formula for Coriolis acceleration, we write it as 2 times of velocity of slider into omega of the rod. This is the formula for Coriolis acceleration. So in all the three mechanisms, Coriolis acceleration is going to exist. Okay, in the crank slider mechanism it is not going to exist because there is only piston moving on the fixed link. That link is not undergoing any kind of oscillation. Okay, let us go to the next question. A flywheel of motor can rotate about the horizontal axis at 2100 rpm. So flywheel of a motor can rotate about the horizontal axis. Its speed is 2100 rpm. While the car moves, flywheel of the motor car is rotating with this speed, and while the car moves in the horizontal circle of radius that is equal to 40 meters. Okay, at a speed of 72 kmph. This is the velocity of the car, or I should say this is the velocity of precession. Then the gyroscopic acceleration of precession will be dash. Okay, so gyroscopic acceleration they are asking us to calculate. So gyroscopic torque is given by, you know very well, gyroscopic couple or gyroscopic torque is equal to I times of omega into omega p. So this omega and omega p is the gyroscopic acceleration. This is called as alpha gyroscope. So now guys, here both the values are given to you. That is omega will be equal to 2 pi into 2100 by 60. So this will be guys approximately around, this will be around 2100, which means it will be 212 or 213 radians per second it is. Okay, that is the value of omega. And omega p that is precision, omega precision will be equal to V by R. Velocity here it is given as 72 kmph, which is 72 into 1000 divided by 3600 into, this is where R is 40 guys, R is 40. So here this will be cancelled, 0 and 0 will be cancelled, 36 panza, this will be 36 twos. This is 20 by 40, which is equal to 0.5 radians per second will be the velocity of precision. So alpha gyroscope will be product of omega and omega p. What is omega? 213 into omega p is 0.5. So this is equal to how much? This is 213 into 0.5 will be approximately 107 or 106.5. 106.5 radian per second square it is. So the closest answer here would be option B guys, that is 105 radians per second square. So this is one type of problem where you are able to see single formula application. Okay, now let us see the next problem. When the axis of first gear and last gear of a compound gear are coaxial, when the axis of the first and last gear are made coaxial, that is a case of reverted gear train guys. That is a case of reverted gear train. Especially this reverted gear train is used in the watches. Okay, and in case of epicyclic gear train, what happens is that the axis of planet will undergo rotation as well as translation. If the sun gear is fixed guys, let us say this is sun gear and this is planet. So planet axis will undergo rotation and translation. So if you are removing the arm, then the planet axis will experience only the rotation. Okay, so that happens in the epicyclic gear. So now our question is only limited to the condition of the axis. That is, if the first and the second axis are last axis gear, first and the last gear axis, if they are coaxial, then it is an example of reverted gear train. Okay, so option B is the answer. Next one guys. The center distance between the two involute gears is equal to dash. So now guys, the center distance, and here where R, small r and capital R are the radii of the base circle. Okay, so center distance is given by radius of pitch circle of pinion plus radius of pitch circle of gear. Okay, so now guys, radius of base circle is given as small r. So radius of pitch circle will be equal to that is r by cos phi guys, it is r by cos phi it is. Okay, so now here center distance will be equal to capital R by cos phi plus small r by cos phi. That is summation of radius of base circle of pinion plus summation of radius of base circle of gear divided by cos phi will give us the expression for center distance. Okay, will give us the expression for center distance. Similarly, guys, if you want to calculate maximum length of path of contact, okay, so maximum length of path of contact, this is another relation, maximum length of path of contact, that is given by radius of pitch circle of pinion plus radius of pitch circle of gear into sin phi it is, into sin phi. Okay, this is another important relation. Please do remember. So basically here center distance is radius of pitch circle of gear plus radius of pitch circle of pinion. So as per this, guys, the correct answer is option C. Option C is the answer. Okay. Generally we designate small r and capital R for specifying the pitch circle, but here it has clearly mentioned that small r and capital R are used to represent the base circle radius. So option C is the answer, guys. Okay. Now let us go to the next question. The effort of Porter governor when the arms of governor are equal and have the equal inclination with the axis of the governor spindle. So effort, guys, effort is given by a simple expression when it has given the standard case. So effort will be equal to C times of small m into capital M times of G it is, guys, which is nothing but C into small w plus capital W. So option A is the answer, guys, for this question. And if you are interested in calculating the effort for watt governor, then in case of watt governor, capital W will be equal to 0. That is, no sleeve mass will be there. So in that case, in the watt governor, effort will be equal to C times of small w. All right. So this is another question from the governor's chapter. Right. Let us see next question. For complete balance of several revolving weights in different planes, the condition is for complete balance. So guys, here complete balance means it is saying that it should be statically and dynamically balanced. It says both static and dynamically balancing should be obtained. So if we say that the vector summation of forces must be 0, then we call it as static balancing. Okay, and if these two, that is vector summation of forces and couples, if these two are included, then we call it as dynamic balancing, dynamically balanced, because at the large force, at the large speeds, this what we call unbalance is going to produce or exert the vibrations, or it is going to exert dynamic loading on the system. So that is why if the systems are statically balanced, then we are going to operate those systems at very lower speeds. Okay, so for this question, option C is the answer. Okay, let us see the next question. The condition of balancing the reciprocating masses. The condition of balancing the reciprocating masses of a reciprocating engine is to balance. So when we are dealing with reciprocating masses, so generally we will be considering, or there will be a unbalanced force which is written as mr omega square, or mass into acceleration of piston, which is mr omega square times of cos theta plus cos 2 theta divided by n. So here this force is split into two parts. One is the mr omega square times of cos theta plus another one is mr omega square times of cos 2 theta divided by n. So this part we call it as primary unbalanced force or primary force. This primary force will also definitely cause some couple, all right? And this portion or this force is called as secondary force or secondary unbalanced force. So this secondary unbalanced force is also going to exert some couple on the system. So now, if you consider an example of four inline cylinder engine, in that engine especially, the cranks are kept at 90 degrees. So when you keep the cranks at 90 degrees, the angle between the individual crank is 90 degrees. So when you are keeping that, we are able to eliminate the effect of unbalanced primary forces. We are able to eliminate the effect of primary couples. We are also able to eliminate the effect of secondary unbalanced couples. But unfortunately, in only that case, we are able to see that secondary unbalanced forces are non-zero. Those cannot be eliminated. Why that they cannot be eliminated? One thing that is happening. And secondly, guys, this value of n, the value of n is greater than 1, which means that secondary force is lesser in terms of magnitude compared to primary forces. So in the four-cylinder engine, we are able to eliminate option A, B, and or option A, C, and D. Okay, but we are unable to do, or we are unable to eliminate the effect of unbalanced secondary forces. That is not possible. Okay, so generally four-cylinder inline engine is preferred in many of the applications. Okay, so here the purpose of balancing is to either eliminate the effect of unbalance or reduce the effect of unbalance. So here we are able to eliminate 75% of the unbalance, but 25% is there in the system. And although that amplitude of unbalance is very less, so that is why four-cylinder engine is preferred. So but when we say that is balancing of reciprocating masses, we need to satisfy all the conditions. Okay, all these four conditions are required to be satisfied. But in reality, we will be able to either remove all the three or all the four. It is not at all possible. That is why, guys, we balance the reciprocating masses partially. Okay, that is the limitation here. But in rotating masses, we can attain the full balancing or complete balancing can be obtained. But whereas in reciprocating, only partial balancing is obtained. So due to that partial balancing, we will be the system is going to experience some effects that could be in the form of hammer blow or what is traction force and swaying couple. All these are the effects of partial balancing. So these were some of the sample questions, guys, from the various topics we have seen, and please go through these questions once again and try to solve many other questions from the public examinations, and all the best for your exams.